Hello guys, in this video I am introducing you to Inversion. Inversion is a family of structured language models designed to solve the speed, reliability and reasoning issues in the traditional AI systems. This is just an introductory video. I already have requested the access to this model which seems to be closed source. So as soon as I get the access, I will also show you the hands-on video on different tests as I always do. But for now, let's look at what exactly this inversion model is and what it is doing. This is the first generation model from Raisana and it is the state of the art in structured tasks. These structured tasks include function calling, extraction, summarization, while running up to 100% faster with 10 times lower latency and outputting 100% reliable structure with 10,000 times less overhead than the best alternatives. If you look at this graph here, you can see that on the speed matrix, the inversion TSM and inversion SM have beaten Mixtral GPT 3.5 and 4 to a large margin. Even GPT-4 is 167 times slower. That is amazing. And this inference speed in characteristic per second across 600 extraction and reasoning tests. If you look at ability, we make it like this. Okay. On ability, GPT-4 is still good, but if you see here, inversion SM has beaten rest of the lot. On the overhead, you can see that inversion is the fastest. And reliability again, inversion is quite good in terms of reliability. It is highly accurate. Now, this is basically the percentage of invalid in output data structure across 600 tasks. And in terms of latency, both inversion SM and TSM are the fastest, which is quite surprising. Now, they started building these inversion models back in February 2023. And the goal was that inversion models should do more with less. They should use less compute, less time, and less data to produce outputs with higher quality, reliability, and reasoning. They were inspired by the newfound abilities of general purpose LLMs to understand systems and glue together human intent and machine action through natural language and structured data. As they have also built products on top of these models, they have found out that the models were far too unreliable, expensive, and slow for production use in structured data tasks. And that is where they created this new kind of model that could handle their workload in the real world at scale. The key insight is that structured inference is fundamentally accelerative, and that if we really start building models that can always reliably output structured data with constraints, then we can massively improve both the speed and quality of the output. And that is where they have really excelled in these new models with workloads like function calling or actions workflows or dynamic UI generation, down from around 1 minute to under just 200 milliseconds, which is roughly the time it takes for a human to perceive a response as intent. How amazing is that? They also wanted to ensure that the outputs would always match the data types they expected. In their case, this meant being validated against a JSON schema for function arguments or components props. If you go through this blog post, they have various other tasks, benchmarks, which they have tested this on, and I will drop the link in video's description. For example, if I scroll through, one of the interesting bit was this one, type errors. This is the percentage of invalid output data structures across 600 extraction and reasoning tests, which I also showed you above. This inversion compiler has really done wonders in terms of this. Now, the way it actually works is that, especially the inversion, that why is inversion so far ahead on multiple fronts that might otherwise seem at odds with each other, demanding a trade-off like constraint and speed. When they started with inversion, it was actually slightly slower than similar models, barely faster than the strongest model, and barely more reliable as of early last spring in 2023. So that is why the whole story is quite fascinating. The first step they did was to achieve guaranteed structured on common JSON types, which is where the compiler originated. Next, they leverage the compiled structure to invert the inference process using the constraint of the output to dynamically scale up and down the amount of compute required to produce each token. You can think of this as an switching on and off large clusters of individual neurons in the model based on the position within the output structure instead of only modifying token sampling. Mathematically, this is a projection from the full model onto a smaller model with undesired sublayers pruned away. So this is not the end, this is just a start for inversion. They're also working on a fundamentally new class of models for the next generation of inversion, which will be inversion version 2. They're not ready yet, but I think there'll be magnitude improvement across the board when that comes out. So let's see. I hope that they also work on some of the multilingual support with deep understanding of dialect and personal nuances and social nuances. That will be really, really cool. And last but not least, this is built for developers, and you will find a lot of APIs and stuff if you go through their docs, and it is full of nuggets in various languages. Like so far, I have seen Zord, Pydantic, and a lot of other stuff. So check it out. And as I mentioned earlier, as soon as I get the access to their model, I will create another hands-on video, and then I will show you if whatever they are saying is true or not. That's it, guys. Let me know what do you think about this model and share your comments. If you like the content, please consider subscribing to the channel. And if you're already subscribed, then please share it among your network as it helps a lot. Thanks for watching.